Well, welcome back. Thank you for sticking around. Everybody here you're the best. You're still here. Cream of the crop. So our next speaker is John Harvey, going to present on sustainability matters. It's not just a buzzword. John Harvey is a professor of civil and environmental engineering at the University of Cal Davis, director of the UC Pavement Research Center, and director of the newly created City and County Pavement Improvement Center, which is a consortium of cities, counties, University of California, and California State University. He's principal investigator for projects for research, development, and implementation for a wide range of pavement technology, pavement management, cost, and environmental topics for the California DOT, or Caltrans, FHWA, FAA, Cal Recycle, the California Air Resources Board, and the Transportation Research Board, as well as other state DOTs and industry. He's a professional civil engineer in California. So with that, I'll hand it over to John. All right. Get these papers out of your way here. There's your remote.
Thank you. Well, thanks for having me. And that was sort of the long introduction. I always forget how long that takes. My usual introduction I prefer is if it's hard, flat, and on the ground and affects your life, we're working on it. So going to do something a little bit different. How many have heard of life cycle assessment? Okay, good. All right, well, I'm going to skip some of those slides then. Very good. So we are working on life cycle assessment. Not quite sure how to advance this. Green button in the middle. Okay, got it. And we're working on life cycle assessment. I want to give you kind of an overview of some of the stuff that's going on, and then a look forward about where we think it's going. Particularly focused on recycling and reclamation. So most of you are familiar with these things. It's sometimes good just to review some of the numbers, and these things just keep piling up. It's kind of like, if I can push it this far, let's see if you can push it a little farther. There's some executive orders to reduce greenhouse gases to 1990 levels by 2020. Let's see, that's next year. 80% reduction by 2050. I hope to still be around by then. And AB 32 has reductions. This is affecting all sectors of the economy, particularly some of the big industrial sectors that we're involved in pavement, namely the cement and asphalt industries. There's an executive order that requires a reduction of greenhouse gas to 40% below 1990 levels in 11 years. That was made law, and then the most recent one was a carbon neutrality, which means that we need to be emitting a lot less, but to hit that goal, we actually have to be absorbing some carbon somehow as well. And I've kind of focused on greenhouse gas because that seems to be the environmental tail that wags the dog a lot in the state. But some of the other things that we really need to think about is we have some of the air districts with the worst air pollution, particularly in the Central Valley, some parts of Southern California. And so we have a lot of other environmental issues that we need to be tracking as well as scarce resource use. So this is a graphic of some of these, and this is, I like to go back and look at this once in a while. Guessing that's the pointer. Whoop, no. That's the backwards one. Okay, so the first law was passed by Arnold Schwarzenegger in 2006. You see that BAU? That means if we don't do anything. And that BAU actually right now, notice that it went down. Mostly it went down in the wrong way because the economy constricted and people weren't doing anything. Particularly they weren't moving around very much. And so everybody was patting themselves on the back because everything was going down, and then the economy started to turn around. And you see the BAU, the business as usual that was drawn there. Well, that's actually moving up right now in the last 2 years at a much steeper rate because people are driving quite a bit more. And they're not hitting some of the vehicle fleet changes that they're aiming for. But the steepness of that curve is amazing. And how we plan to get there, basically there's no magic bullet. There's about 1,000 things that need to be done. One of the things that we need to do to even move in that direction is to prioritize those. So that we do that, particularly focusing on where the changes that we make actually make our economy more efficient, win-win, reduce cost and reduce emissions. And then if we start to get into the things that need to be done that are going to start to put a drag on our economy, we need to go into that, understanding that, and how to prioritize that. So that's kind of our goal at UCPRC. That's the message that we're trying to bring in our federal work and in our state work with everybody that we're talking to about these things. And a key part of that, well, definitely public awareness hasn't gone away of this. I'm from Chico, and I can't get a motel room in Chico now because it's full of 10,000 refugees. So public is very aware of this, and the economic costs of this are staggering as well. And that one fire also reversed all the greenhouse gas savings for that year and everything else that we did in the economy. So there's kind of a vicious cycle that's starting here that we need to turn into a beneficial cycle and start trying to work this. So the public support for this is still very strong, this kind of stuff. Now, the other thing that we face in the pavement materials area is shortages of aggregate, particularly local shortages near urban areas, and some quality issues with some of those. One of the things that we look at when I talk about the LCA is that I believe it's the 5th most important commodity that we move on the highways in California is sand and gravel. So we are destroying, in terms of freight tons, mile tons that we move. So we're destroying the roads, hauling the aggregate that we're using to fix the roads. And that's one of the things that we look at in life cycle assessment, trying to get a full system look at this. Another thing that is starting to be interesting as I go to some of the refining meetings periodically, and what's Exxon's projection of oil demand over the coming years. And as most of you know, transportation fuels, gas and diesel, are what drive the refining industry, and we produce asphalt as well as a co-product in many ways. Still makes a profit, but it's not what drives the investment in the industry. If we start diminishing the transportation fuels over the next 10, 20 years, how much of a market do we have to still refine oil is one of the questions that we're looking at. So some of these issues of the supply is still higher than demand for asphalt right now. The 3 biggest refineries in California over the last 10 years stopped making asphalt by putting in what I call a weapon of mass asphalt destruction, also known as a coking unit. Costs about $2 billion, and you burn your asphalt to produce a little bit more gasoline and diesel and some pet coke. So recycling is a huge issue, both from the aggregate issue and from the asphalt. So we have a lot of asphalt and aggregate in the existing roads, and mining these roads is kind of the new paradigm that we're taking a look at. And you're all familiar with all of those. This is a presentation I give to other folks as well. How many have seen this map? Okay, few of you. So the size of the circle is demand for aggregate in California. This was done around 2006, and this was a projection to 2050. The size of the circle is the demand. The purple part is the unpermitted demand to 2050 for aggregate, and the blue part is the permitted part. And I don't think that many new quarries have opened up since then anywhere near these major areas of demand for aggregate. So finite resource use is one of our issues. And the farther you put the quarry from the place where it's used, the more you're hauling sand and gravel, heavy stuff on the roads and tearing up the roads and bridges at the same time. Similar map for Southern California, looks very similar. Okay, I'm going to move a little bit fast through this. This is basic idea of product life cycle. For every product that we have various stages through its life. This is what's called a cradle to grave look at it, from the beginning, mining the material from the earth, to what you do with it when you're done with the product. Each one of these processes has materials and energy coming into it, and waste and pollution coming out of it in addition to the product. Pavement is much more complicated than most materials because it is potentially perpetually recyclable. So we have all these arrows going back. 4 basic stages. Set your goal. What is it you're trying to answer? Accounting, the life cycle inventory. What are those inputs? What are those outputs? And the big one for pavement, which I'll talk about at the end, is how long does it last? Because how long does it last controls the frequency that you have to do the treatments over the life cycle. If I do two things that have same environmental impact of construction, but one lasts twice as long, it has half the environmental impact. And what we found out is we were looking at all the impacts of materials and transportation and construction equipment, but the biggest thing most of the time that controls the net life cycle environmental impact is how many times you have to do that. So that's the life cycle part that we're looking at there. So this is all a part of the life cycle inventory. We then translate those into indicators, impact indicators, and then you look at the results and answer the question that you set out to answer at the beginning. So the questions that we're particularly legislatively we have to deal with are greenhouse gases. We're also very concerned about the air pollution. Finite materials resource are kind of the main ones that we look at, we're focused on. A key part of this is outside critical review, and at the end of this talk, I'm going to invite you all to be spending time looking at the results that we put out and critiquing them. As we put out reports, I want to bring the awareness of the things that we're putting out, and I'm going to talk about some software that we're putting out both at the federal and state levels that I want to invite industry input and critique, and you got that wrong, I don't understand that, that doesn't make sense. And that's a critical part of this whole life cycle assessment process. So these are the Tracy indicators from the US EPA that we look at. Anybody here from a federal agency? If this was a federal presentation, we actually have to black that one out, so that would be a black box on the screen. In many cases. Some of these we are harder to understand and we're not quite as focused on. The main ones, as I said, in California are the global warming and the photochemical smog, which includes particulates and ozone, ground level ozone. And in addition to these, we're concerned about the depletion of resources. We add additional resources to that in the work that we're doing now. So what's the goal of LCA? The key is quantification. A lot of the initial environmental sustainability review that people did was check boxes. Did you do this? Did you do this? Did you do this? Did you do this? But no quantification. How many are familiar with the LEED system for buildings? Okay, so Dave and I built a building, and I'm going to critique check boxes here. We built a building and we wanted to become LEED Silver because we thought this was a good idea. To get LEED Silver, we had to buy a particularly efficient thermostat for our air conditioning. Well, we ran out of money and we couldn't buy the thermostat. In fact, we couldn't buy the air conditioning. So our lab is, we manage temperature with methods other than air conditioning. But we didn't get LEED Silver. So we have zero environmental impact from our air conditioning, but we couldn't get LEED Silver because we couldn't check the box for an efficient thermostat. So we're trying to move things away from check boxes, which sometimes actually will drive you in the wrong direction, and get to actual quantification of flows, inputs and outputs, and impact indicators. And in order to compare things and be able to prioritize and also be able to review your system and figure out where's your hot spot and where you can make improvement as an industry or a contractor, you need to be able to quantify. So the idea is quantification. The other thing is we need to look at the full life cycle. If something has half the environmental impact, but it lasts a quarter of the time, you've doubled the environmental impact. So full life cycle is important. What happens at the end of that life? Full system boundaries. We optimize things here, sometimes here, and we optimize and we get a little bit of a benefit, but we forgot to count this, and this is changes because we changed the system, and that may have a negative environmental impact that's bigger than this one. So making sure that we cast the net wide enough and define the system so that we capture interactions and don't have unintended consequences. And then this research and these indicators are also expanding some to look at economic impacts as well as some social impacts. So our vision for the use of LCA in transportation is to use it where it's appropriate, and there are places where it's not appropriate. Make sure we consider full system and life cycle. We must have good data. Garbage in, garbage out. And this is also the message we're looking to bring out to folks is industry has the best data. How do we work with you to bring good data? Critique our data that we dredge up and collect, but also work with industry to get data. You guys know your processes and what you're doing better than anybody. There's a lot of proprietary issues, but those are things that we're working through with the asphalt paving industry, the concrete paving industry, the cement producers, the asphalt producers, and we're really trying to make sure we capture some of the other most important parts of the pavement industry, which is recyclers and preservation folks as well, reaching out to them. We need to make sure the indicators give us good information, and the goal of this is to create a science-based culture for doing this, and honesty, transparency, critical review, so that all stakeholders are involved in making sure the results make sense, and this leads then to continuous process improvement. The basic way we do this to model this is you have a process, let's say a recycling process, and we need to know what the inputs are coming into that, and we can figure out the impacts of those inputs. We have an output flow of product, miles of pavement paved, for example, and then we have the emissions that come out of that. As we're putting these models together, then we have multiple processes. We have asphalt production upstream, we have cement production upstream, we have fuel, diesel production upstream. All of these need to have their impacts, and then those are feeding in. So we have these series of processes. Here's a model I did a little while ago for a full depth reclamation with cement with an asphalt overlay. And this gives you an idea of each of the different pieces, that each of those boxes is a process that we are modeling the inputs coming in and the impacts of those inputs, the product coming out, it all has to be balanced in terms of production, and then the emissions that are coming out, waste and emissions that are coming out of each of these processes. So when somebody talks about a life cycle assessment tool, it's a bunch of these boxes, these models, put together with mass balances to make sure that the quantities are making sense and that we're capturing this. So this is taking the basic product life cycle, converting it and thinking about pavements. These are some of the things that we look at in pavements: the material mining and processing, transport, the design, and one of the biggest places that we can make innovations using life cycle assessment. People tend to focus on the materials and comparing materials, but some of the bigger issues, the bigger issues are how do we use that material in a pavement design, and the biggest one is construction quality, because construction quality is usually the biggest thing controlling how long is that going to last, which controls how often are we doing this, which is the multiplier for the amount of materials and construction that we're doing. We model the construction. Then in the use stage, we need the pavement performance. Rough pavements consume more fuel, not a lot, 0 to 3% more fuel. But if you're driving up 680 on an afternoon, some of you heading home, if you have 150,000 vehicles a day using that direction of the road, 1% change in fuel is over a year is millions of gallons of fuel and massive changes in the impacts. We're interested in stormwater quality. Rolling resistance is both roughness, texture plays a smaller role, and to some degree the energy consumed by the pavement itself deflecting under the trucks. So those are all areas where LCA is being developed for pavements. And then what do we do with it at the end out there? And bringing it back into these and repeating these processes is where pavement gets pretty complicated. What we want to do with all of this is we can't, truly in our core believe that we can't just focus on, we reduce greenhouse gases, great. Oh, by the way, we went bankrupt while we were doing it. Got to bring cost into this, and life cycle cost, not initial cost, but life cycle for all the same reasons, full system, the impacts over the entire life, so that we can prioritize. And basically what we're trying to get to is we can do bang for buck. How much does it cost, if I do this, how much does it cost to reduce the air pollution or the greenhouse gas that much? If I do that, how much does it cost? I want to focus on the cheaper ways to get there, particularly if those cheaper ways are actually cost savings, which many of the things that we can do in pavement are. How many of you have seen or heard of this document? So this is a federal highways document. If you search FHWA pavement life cycle assessment, you will pop this document up on the Federal Highways Sustainable Pavements Task Group. This was written in 2016 with a lot of input from industry, but at that point, Federal Highways, we were not reaching out much to the recycling industry. This is basically our taking of international rules for all products and bringing them and applying them to pavement systems, the details of how to do this for pavement systems. We've also expanded this to the Federal Aviation Administration in 2019 and revamped it for airfields as well. So this would be a document, if you're interested, to take a look at. Some other milestones in pavement LCA development are the LCA symposia. Have any of you been to one of our LCA conferences? So we began those in 2010 in Davis. They've been in France, in Illinois. I'm going to show you at the end, we're coming back to Sacramento in 2020, and we really like to see a lot of recycling folks getting involved in this and bringing your expertise and your stakeholder concerns to that. These bring together government, industry, and academia to present, discuss, and identify ways forward. How many of you seen this document? Okay, so this is, this was originally, Federal Highways wanted it to be called Sustainable Pavement Systems. And we said, well, we're not certain it's sustainable, and I don't want to go out on the limb and say, you know, that could be an oxymoron. So we got it renamed towards Sustainable Pavement Systems. I truly believe in not patting ourselves on the back and giving ourselves a blue ribbon until we actually achieve what we say that we achieve. So how many involved or heard of Sustainable Pavements Task Group, Federal Highway Administration? Okay. Strongly encourage, that moves around the country. The next one's in Detroit. I'm not sure where we're going to be after that, but if it's coming to your region, if you Google FHW or your favorite search engine, FHWA Sustainable Pavements Technical Working Group, you can go to the website there. These are open meetings. We've got most of the other industries there. We've got state officials. We've got a few local officials and academia there, trying to move this whole sustainable pavements thing forward. A big thing that we're doing is trying to identify the methods to do this and how to quantify the methods. So a lot of what happens in here is working on LCA and how to bring LCA into routine work. There's other information up there as well. So where can we use LCA? We can use LCA for policy. When we change specifications in our Caltrans research now, we usually evaluate those with a life cycle cost and a life cycle assessment and take a look and see what's this going to do to the environmental impacts if we change a specification, if we allow them new material for Caltrans. Design methods we're looking at, regulations we're looking at. One of the things we do in trying to connect with the legislature is sometimes the legislature has kind of an idea, a vision, but the way they write that into the legislation may sometimes actually increase greenhouse. It's a very sexy, simple idea that hasn't really been quantified full system life cycle, and sometimes some of the laws to protect the environment may actually take us backwards, and that's what we use LCA to look at for policy. I'll talk through some of these other areas. One of them that we're fighting a little bit is to bring LCA right now into procurement. And I'll talk about why in a minute, but we are beginning to think about how you can bring this into procurement. The legislature's already tried to go there, and we'll talk about that in a minute. In particular, we're in a design bid build system, low bid system. The places where procurement how you choose the contractor, how you choose the material supplier, have mostly been in design build and design build maintain environments. Our thinking right now, and very interested in critique, is that we should treat this. Some places and legislation has wanted to convert environmental impact into dollars and make environmental impact dollars equal to real dollars of your bid price. And we've really fought that. We really think the way to go is an A plus B plus C plus D, where environmental impact would be a separate category, and they're using a multi-criteria decision, because how you convert those environmental impacts into dollars hides all the results and makes it very, very problematic. How many have heard of environmental product declarations? Okay, so an environmental product declaration is a cradle to gate, not grave, but gate. And it's produced by a material supplier. If we extend that to cradle to laid, then it includes the materials coming in as well as the construction and transport processes up to the time that you open it to traffic. These are produced by industries. Most pavement industries are now producing EPDs. National Ready Mix Concrete, Napa started 2 years ago, 3 years ago. Asphalt Institute started their program last year. Cement Associate, PCA is there. Looking to expand that. What we're trying to do is get these programs up and running with industries so that you're involved in setting it up, rather than you get T-boned by somebody who says, I want EPDs next year, and you're like, not ready to there, and they tell you how to do this. We really think industry should be guiding this and setting this up. Environmental Product Declaration is basically an LCA that produces an environmental impact statement, just like the nutrition label on your Wheaties in the morning. And that's something that a buyer can look at. It's also the main thing we think it should be used for right now, is this information that a designer can use when they're looking at putting their design together. Caltrans is requiring EPDs now. There is a NSSP out there, which the website is down on there. The materials that are in, so that the Sierra Club wrote legislation and wanted to get into the pavement industry. They were able to be pushed off for a little bit, but there is legislation affecting the steel industry. Steel industry is the main one that in terms of transportation infrastructure. Caltrans is piloting this. We're trying to get ahead of legislation and get it worked out right before somebody writes a law. Who's covered in this right now is hot mix asphalt, concrete, aggregate, and structural steel. Our recommendations with regard to procurement were that you should take 3 to 5 years before you even begin to consider procurement. You really need to develop the rules and reporting standardization, what's called harmonization. Make sure that all industries are following similar approaches. They're defining their systems similarly. They're calculating things similarly. That's the process we're going through nationally right now at the federal level, is working with industries to try and sort out these things. Now, each industry has its own stakeholder group saying we should calculate it this and we should do it this way. So balancing that and make sure all the stakeholders are involved. Until you can compare things sufficiently in a transparent and fair manner, we're highly recommending to the legislature and others, don't go to procurement. But the pressure for this is extreme right now, is high. So right now we're through the Caltrans pilot program, we're comparing and identifying, and there's a federal project that is identifying common data that all industry can use for background, like your fuels, that everybody uses the same fuel data. Are we ready to use pavement tools? This is the pyramid. We want to get to the top and use this stuff in tools, but to do that we need to have a framework. That's what we want to do. We need to have a framework, which we now have. We need to have data definitions. That's what's being finalized right now. We need to have data. We have sufficient data to get started. Definitely needs improvement. This is becoming available and being reviewed. This is what the Sustainable Pavements Task Group is doing in part, and the industry organizations. And we're getting ready to produce tools right now. This is project development in a design bid build system, starting with planning. And there are LCA type things going on. There's a lot of box checking going on right now. And planners right now are actually making materials decisions without real materials data, pavement materials data. And so there's kind of some decision making going on in a data poor environment in the planning stages right now. At the network level, Caltrans has implemented LCA into their pavement management system. So when Caltrans runs a 40-year scenario for their work for the next 40 years, it is calculating the greenhouse gases for all the treatments, including recycling, concrete, asphalt, using the existing data that we've produced. For conceptual and final design, we're producing a software that should be ready. It's going to start being tested by Caltrans in about a month, called LCAP. And then procurement is where incentive, disincentive on EPDs is. This is not there, but I think the pressure for this, we got to move as fast as possible to make these fair and transparent. I don't think the pressure is going to go away to begin to consider this in procurement. I'm going to skip through that a little bit. Key other thing is the use stage. So each of this is a life cycle. You have the initial construction, M is maintenance, R is rehab. You have initial materials and construction, and then you have the use stage where the vehicles are using it. So the vehicle interaction, getting your smoothness, that's in the Caltrans pavement management system, that's in the tools. If you don't get it smooth, you're using more fuel, particularly the more vehicles that use it, your environmental impact goes up if you're not getting the smoothness, and the models will be calculating that. The goal that we're working for at the state level, and this is kind of becoming a model for some other states, National Research Council Canada is working on this, is that all of our tools use the same data in Caltrans. So the tools that we have in Caltrans are the pavement management system, construction productivity software, our pavement design software, our life cycle assessment, and our life cycle cost analysis programs. The idea is that we get to a place in the next few years where those are all web-based, and every time we update the traffic data, every one of our tools gets new data. Every time we update the environmental impact data, the pavement management system data gets it, and the LCA programs get it. Quick, I'm about at my time here, but quick look, and I'm not going to go through the numbers here. I'm just going to give you a snapshot, hopefully as an appetizer, that you start thinking about. This is where we're at right now, is modeling these things. These are some different CIRs with different thicknesses, some different FDRs with different stabilizations. We put a rubberized overlay on all of these versus a thicker HMA overlay and an HMA mill and fill. So these are some things. This is in a thesis that's coming out, some papers and Caltrans reports coming out. This is the look at where is the impact. This is cradle to laid. So in the materials, in general for pavements, the materials is your major source of environmental impact. Transport's in there a bit, construction is in there a bit, but the main thing is your materials. And of your materials, the main impacts, it's primarily controlled not by the aggregate, it's how much cement you use and how much asphalt you use, because those have disproportionate environmental impacts per their contribution to the mass of the mix. Out of that, you produce a cradle to laid comparison. As you increase the amount of stabilizer, you're increasing the environmental impact. Now, if I looked at this, I would maybe not do FDR. But that's absolutely not what you should be looking at, because the next question is, and what's going to drive it more than materials, is how long does it last? And how long is that FDR material going to be out there providing that support to the surfacings that I'm going to be putting on that? So the critical next part of that is the pavement performance models. And this is what we mine the Caltrans pavement management system and are putting together these pavement performance models. This is past history. And we continue to improve these as we go. We also augment these models with some mechanistic modeling and the accelerated pavement testing work that Dave Jones probably talked about on Tuesday. So those are all the pieces that get put together to calculate the final environmental impact. So thank you, and I want to call out June 3rd to 6th in Sacramento. Pavement Industries are going to be there, academia, state, local, federal government. This is sponsored by TRB, AFD 40, and Federal Highway Administration. And I do also just want to put a shout out. We have started this new city and county center. That's the website, and working with CSAC, SEAC, and the league. Thank you.